Refraction. The phenomenon of refraction occurs when a wave propagation is occurring and the wave goes into another medium, which causes the wave to bend or change direction. In this example, this stick will be the actual wave, and the medium itself right now is the actual air or space inside of the room. As this stick passes into another medium, here the water refraction is occurring. Now this might be difficult to see on this video, so I highly recommend that you try this at home or the next time you're around a body of water to demonstrate refraction. So if you can see it really closely, once the stick entered the water, it bent or changed directions. So this is refraction happening. So to define refraction, it is the bending or the change of direction of a radio wave during propagation when it enters another medium. I'm here standing on the Woodrow Wilson Bridge that connects Maryland and Virginia, overlooking the nation capital. I'm going to demonstrate the phenomenon of the fraction of a wave, in this particular case here, a sound wave. What we have here is a noise barrier on the bridge. As I proceed to walk towards the end of the barrier, you'll notice that the sound of the highway traffic gets louder. As you can see, you can barely hear my voice. Okay? As I walk back toward the sound barrier, and as I proceed down, the sound muffles. What is happening in this process is that the sound waves from the highway are being diffracted by the sound barrier. So in this case, diffraction, the bending of a sound wave, a wave around an object is happening. If I was tall enough and could get to the top of the sound barrier, the noise will probably return to its normal decimals. So in a nutshell, this is the phenomenon of diffraction happening. There are other examples out there that use water or light, but in this case, something that we all should be aware of: sound barriers on highways. You see them all around everywhere. Diffraction is in work. Thank you. Reflection. Reflection is something that we all should be aware of. When you look in the mirror, you see the reflection of yourself. In wave propagation, this phenomenon is still basically the same. As radio waves are transmitted, or as they travel through from the transmission to the receiving end, there are objects that will cause the wave to reflect during its travel. In this demonstration here, I will simply use the flashlight and point it into the mirror, and the light will reflect from the mirror to the wall. As you can see here, the light goes to the mirror and it is reflected over here to the door. This same basic principle is done during wave propagation. Reflection can be caused by numerous things: man-made items, Mother Nature, deserts, oceans, are all reasons to cause radio wave reflection. Scattering. In this demonstration, I will provide an example of how this phenomenon occurs. In scattering, when the wave propagation is happening, something causes an interference in the transmission, which causes the transmission path to scatter. In this example, I'll be using a flashlight pointing at crystal balls. This flashlight or light propagation is an illustration of the radio wave going in a transmission pattern. Once the interference of the transmission by the crystal ball, scattering will occur. As you can see, the light demonstrates the propagation. As I move to the left here, you can see that the interference caused by the balls have caused the light particles to scatter. In this demonstration here, this happens during transmission of radio wave propagation. This interference can be caused by Mother Nature in the form of water or other atmospheric changes. So, in a nutshell, scattering is the scattering of a radio wave caused by an interference.